want to compare results from two different populations. Like again, men versus women is a common one. What do men and women think about a certain thing? More women believe in rehabilitating our criminals, and men believe in the death penalty. I don't know. I'm just kind of thinking out loud, right? So we can compare two different samples and see what they, to one particular idea. So we can conduct either a two-proportion confidence interval, which we'll look at in a few minutes. So it's still looking at an interval. When we do that, we're going to be looking at the difference between them. Okay, so we're going to be looking at, let's say, the difference between males and females, or the difference between whatever our two population or our two samples are going to be coming from. Or we can actually conduct a two-proportion hypothesis test, a two-proportion Z-test. So we're going to look at both of those today. There is a formula for the two-proportion confidence interval. That it's a little bit different, but it's not too bad. I think that if you look at the formula, you get kind of a little bit overwhelmed, but I don't think it's necessary to be overwhelmed, and I'll kind of try to break it down for you. You're going to find that the methods are very much the same as a one sample. We're still going to do our same 5 steps of the hypothesis test. A confidence interval, you're still going to find your statistic, and you're going to add or subtract your margin of error. It's just that some of the formulas are a little bit different. That's all, okay? So that difference is going to be, the notable difference in the calculation is rather than one sample, you have 2. So we're going to be looking at the difference between the 2 samples. That's really the only difference between them, okay? All right, so when we are comparing two proportions, we're going to define a new random variable, which is the difference. So when we talk men versus women, plants receiving fertilizer versus not fertilizer, that kind of thing. So what I mean is this. We're going to be looking at a new, let's call it a new p-hat, and it's going to be the sample minus the second sample. Okay, and the order in which you subtract sometimes matters, sometimes doesn't matter. We just have to kind of be mindful of whatever way we define it, that we're consistently doing it that way all the time. So if we do men minus women, we're always doing men minus women, that kind of thing. Okay, so just however you're going to define your new statistic. Much like when we talk about your that would be for a let's do the confidence interval. Okay, so what would the formula be for the confidence interval? It's going to be your statistic plus or minus the margin of error. Margin of error is z star times the square root of something. Would you agree with that? Just kind of general formula, right? What's going to go in the first set of parentheses, do you think, for a confidence interval? What normally went here when we did the one proportion z interval? P-hat, right? So now that was if we had one sample. So what's going to go here when we have 2? Yeah, P-hat, the difference between the 2, okay? Perfect. So we're just going to write that in. So just the difference between our two sample statistics, okay? Does anyone have their formula sheet handy? If you do, take it out for me, okay? I'm going to grab mine. It's a good idea to look at that formula sheet, because what goes underneath that square root, do you remember? By the way, it looks like some of you guys borrowed them during the test and didn't return them. I had 2 extras back there that I told Mr. Hall I would loan out. Anybody borrow one by chance? You gave it back in? Okay, well, I don't know where it was, but can I borrow yours, Amanda? Yeah. Thank you. Okay. So if you look at the 2 sample difference of proportions, it's down here in the bottom right-hand side. That is the formula that we're going to use for the standard deviation, okay, or the standard error when we're talking about a confidence interval. So if you look here, we're going to say p-hat 1 times q-hat 1. They write 1 minus p-hat, right? Do you see that? Rather than 1 minus p, is it okay if I write q? Or should I write 1 minus p? Write q? I'm fine with that. Do you see that formula that down there that's written down there? So you have it, I'm sorry? Yes. Well, that's a very good question. It depends. It's a sample size for each of the, so not necessarily, okay? Do you have to have the same sample size for the two populations? Probably not. So we should probably say this is the sample size from the first population and the sample size from the second population. Thank you for pointing that out. Okay. So that's the confidence interval. It's really nothing new. It's your statistic. We're just looking at the difference now. Plus or minus the z-star, which is the same z-star we've always found before. But we have a little bit of a new formula for the standard error in this case, because it's a confidence interval. We don't know exactly what P and Q are. Okay? All right, so we identified it on our formula sheet, so we're good. I'd like to look at a confidence interval. So here's an example of one that we're going to do. Okay? So this is one that you should at least write down key information. I realize it's kind of wordy here, but let's try to see if we can come up with how to create this interval. Okay? So I'm going to pause the recording for a minute. I want you to identify key pieces of information, and then we'll go from here. Okay, so we've identified that it's two samples because of the 506 men and the 520 women. Perfect. Why is it proportions? What in the problem tells me proportions? The percentages. Perfect. So we know we have a two proportion z-test just based on that information alone. Okay? Coming up in a couple of class periods, maybe as soon as Thursday, we'll have to see. We are going to start talking about a completely different kind of hypothesis test, and it's based on means and averages rather than just on proportions. Okay? So I'm going to be kind of asking you that same question every time we read a problem. Is it proportions or is it means? So this is means, this is proportions and two sample. So we're going to identify our test, or we're not doing a test, we're doing an interval, but we're identifying it. Okay? Now it tells us to construct an interval. Okay? So we're trying to figure out whether or not men are more intelligent than women. Okay? Anybody have a parent? My dad used to tell me that women are smarter than men. You're always smarter than me. He always trying to make me feel good, right? I'm like, whatever, Dad. PhD, like what? Just whatever. You're smart. Get over yourself. Mm-hmm. But my husband and I have this thing. Who has the higher IQ? We don't know, but who knows? So let's see what we think. Okay. If we're trying to create an interval based on the formula that I just gave you, what information do we need to kind of draw out of the problem and write down? P hat for the men and P hat for the women. Let's write that information down. That's a great way to start. I agree. And rather than write 1, 2, can I use M and W as a subscripts? Are we okay with that? Because that's clear to me. Okay, so I'm going to say that P hat for the men is going to be what? 0.28. Okay, so out of the men, 28% thought that men were more intelligent. Okay, and we should probably identify that we're talking about men being more intelligent, right? Okay. That would give you the numerator of P hat if you're trying to write it as a fraction, which you can absolutely do. So if, for example, I did, I'm not sure why that's not working. If you wanted to change that to a fraction, you could 28% of 506, so 0.28 divided by 506. And unfortunately, what am I doing? 0.28 times 506. And you get some sort of decimal, right? So you could put that over, you obviously 141, and then, I don't know, maybe my left leg and my right arm were like, but the rest of my body agreed with this, so you can't do that, right? So that's why we're just going to leave it as 0.28, okay? But yes, you could, but let's go ahead and leave it as a percentage. All right, how about for the females? How many, when we asked the females, 14% that men were more intelligent. Okay? So we're trying to decide, is there a difference between the two populations? We're not trying to decide who's more intelligent here. All the confidence interval is going to do is create an interval that says, is there a difference between them? The good thing about two sample confidence intervals is you're always trying to capture the same thing. I said the word always. That's exciting. Okay, because I can rarely say always. Okay, what do you think? Think about general terms now. What am I trying to capture in the confidence interval? What number? Okay, and that's what I would expect you to say, but no. Okay, but let's think about this for a minute. I'm going to rephrase my question. You ready? Maybe you have a different answer. A confidence interval is trying to capture, or what we're trying to do in this problem is see, is there a difference between what men and women think? Okay. Devin, you want to take a stab at it?
Trying to find the true difference between the proportion of men versus women.
So if there is no difference between what men and women think, what number should we capture? 0. Good. Okay? So every time in a confidence interval, if we capture 0, there's no difference between what men and what our two populations think. Okay? That's kind of important. I'd write it down. So maybe we should write it down somewhere. Okay? So in a confidence interval, really? What am I doing? Okay. So in a confidence interval, let's say you're looking to capture 0. By capturing 0, that means there's no difference. Between the populations. Oh, I should say really between the samples, but okay? We okay with just that generalization in terms of confidence intervals? And really, even if we get to two sample inference with means, we're still going to be trying to capture 0 with confidence intervals. Okay, you're still looking at the difference between them. Okay. All right, so let's go back to this here. Let's see if that's actually going to work out for us. So how do I begin? Okay, standard error because it's a confidence interval. Sure. So we know that we're going to have some information here. We're going to have a z-star here, and we're going to have a bunch of numbers in here. Just throw it on my desk for me, Brian. Thank you. Let's start at the beginning. Let's start at the far left. What number goes in there? 0.28 minus 0.14? As long as you start that way every time, I'm okay. You can go the other way as well. It doesn't really matter. Okay? So 0.28 minus 0.14. I'm good with that. Okay? Now what? The z-star that's associated with 95% doesn't change. It's still the same as it was with the 1 proportion, so it's 1.96. I agree. Okay, and then we have our formula. So 0.28 times 0.72, and then the first population of men was 506. I agree. And then over here, we're going to have 0.14 times 86 divided by, there you go. Okay. Here's the good news. Okay. If there isn't what? The good news is that if you can just kind of plug and chug and tell me what numbers went in and you can get that, your calculator will actually create the interval for you. Okay, so in terms of shortcuts, in terms of what I expect you to show me in terms of work on this, is the numbers plugged into the formula and then the actual answer. Okay, so I'm okay with you not having to number crunch here a little bit and type it into your calculator and whatever. Is that the way? Is that the correct? Is that the correct way I'm supposed to say it? Now I should have said turn up. Okay, cool. All right. I'm learning. All right. So where do I find the interval? Where do I go? Do you have any question? You're going to answer my question. All right. First, go for it. How do I even get there? Okay. So stats, tests. B, yeah, 2 proportion Z interval. That is correct. And you know what? Lena, you okay? You need some water? You're good. Okay. The good news is if you happen to pick the wrong one, you won't have the information to put in, if that makes any sense. Okay? So if you pick this one and you don't have all the information, something's awry. Okay, so let's hit enter. Ooh. And here is wherein lies Sammy's question from early on and kind of what we were talking about. We put 0.28. What's X1? Well, that's 28% of our population. So in a way, Sammy was kind of right in what we need to plug into our calculator here, okay? So what is 20? I'm just going to put point, and if I do this, by the way, it's going to give me, it's going to yell at me, just so you know, because it gives you a decimal, okay? And it doesn't like that decimal, so we're going to have to come up with probably rounded up to 142, okay? So let's do that real quick. And then that was 506. Yes, okay. And then X2, or our second population, is 14% of 520. Oh, not tangent. And again, so that should round up to about 73. Okay. Out of 520. We have a 95% confidence interval, and here we go. Okay. So our confidence interval was 0.091, 1.89. So what? Huh? Okay. Is there a difference between what men and women think about who's smarter than who? There is, because 0 was not captured. What's even more awesome about a confidence interval is we can actually use it to estimate the proportion of the difference. Okay, and that's what this is. So how would I interpret this interval? How would I write my conclusion sentence here in this case? We're 95% confident that something happens. So what? There is a difference between men and women thinking whatever of about 9 and 18.9%. That between 9.1% and 18.9%, there is a difference, sorry. Because that's what we're calculating, is a difference between, right? So we are 95% confident that there is a difference between 9.1 and 18.9% of what? What was this? What's the context? That men, say it, Stephanie? Right, that in who thinks men are more intelligent than women. So here's my question. Do more men think it, or do more women think it? It goes back on how we defined this. We did men minus females, didn't we? And we got a positive solution, which means that more men believe that more men believe that they're smarter, right? So we could even go as far in saying that if we wanted to. That might even be a better way to say it. So let's go ahead and say that. We actually think, okay, we are 95% confident that, hang on, let's do it this way. 9.1%, between, sorry. 9.1 and 18.9% of more men, how do we say this, of more men think they're smarter than women. More smarter. I can't, that bothers me to even say that, like, in a language sense. Thank you. Okay, so of men think they are more intelligent. Okay, I like that better. Men more intelligent than women. I even highlighted it. That's okay. No, that's okay. Okay. Are more intelligent than women. Right. So 9.1, between 9.1 and 18.9% of men, as compared to women, right? So about, let's just pick a number in the middle, I don't know. 10% more men think they're more intelligent than women. That's what I mean. The difference between men and women is somewhere between 9.1 and 18.9. Okay? Yes. Compared to women. I think that even, I like that wording in there too. That's fine. Of men compared to women. Think men are more intelligent than women. I like that. Sometimes we have to hash through the wordings together so it's meaningful. Okay, so we're 95% confident that between 9.1% and, why is it doing that? And 18.9% of men, as compared to women, think that men are more intelligent than women. I like that. That's a nice wording. All right. Really, there's nothing more to this than what we've already done, except for we have to do some subtracting in the beginning, and we have kind of a new formula for standard error, right? But is it a formula you have to memorize? No. Is it on your formula sheet? Yes. So really, there's nothing new, except for new formulas. And what are we always trying to capture? 0. Okay? And we didn't here, and that's okay. Yes? Okay? All right, Charlie, hope you're listening and watching. We're thinking of you. Hope Signet's just awesome. Tell Mr. Craddock, yo. YOLO. That's probably not right, right? Okay, okay. All right. That's all right. Have you seen the Jimmy Fallon where he says all the weird words, like just like I'm trying to do, in totally the wrong context? I'll find it for you. I saw it on Twitter last night. I was like, oh, he's coming in. All right.
Twitter?
Follow me. Yes. Say that again? Yes, sample proportions. That's right. Okay. You ready? Why? Okay. I'd like to do a different problem, can we? Okay. Because I'm into this whole, well, not into it, it's kind of a couple weeks old now, but this whole gold black versus, or gold white dress versus blue black dress. So why don't we do our own hypothesis test based on that? Can we?
What if you've seen both?
Because we're going to do two proportions. Okay, so hang on. Hang on. I'm going to bring up the picture. Maybe. We'll see if I can get it. So look at this picture of this dress and move to the side of the room accordingly if you are a blue and black dress versus a white and gold dress person. Okay? So if you are blue and black, you are to be on this side. And if you are a white and gold, you are on this side. Y'all are wrong, just so y'all know.
You see that?
I see white and gold completely.
Yeah, I see that.
I think you're all nuts. It is white and gold. What is wrong with these people? It's white and gold, right? I know. I know it is. I know. All right, so you're white and gold or blue and black? There's only
Yeah, I'm sticking to
1, 2, 3, 4, 5. There's 6 of us in this class that think it's blue and or white and gold. That's it. It is. I mean, like, it is. No, I'm just kidding. I know it's not, but that's what I see. Okay.
I made that dress. I can tell you it's running.
All right. Are we ready? Shh. So let's go back to Hunter's question. Okay, and we want to figure out how can we do. We have two opinions, right? So we have to think about if we just did a one proportion z-test, wouldn't it just be our one sample of our class, right? And the one sample would be, there's no difference between them. Half of you think, that it's blue and black. Half of us think it's white and gold. And we could do a one proportion z-test that way. Right? Our one sample, our one class. Do you agree? Okay. What Hunter said before I brought the picture up really made a difference. Say it again. Why is that now make it a two proportion z-test? Because again, let me repeat what I said earlier. If we just did a hypothesis test on what our class thinks of this particular dress, we now have one proportion, right? Just one. Those people who think blue and black and those people who don't. Why does introducing male versus, go ahead, Hunter, answer your own question. Why does introducing male versus female now make it two? Okay, Jordan, you want to add to that? Okay, so is there a difference? Maybe does gender have an influence? Is gender is gender one of the factors that make you see blue and black? I think that's awesome. Okay, want to add to it? Did it?
Yeah, I see white and gold now. It's making me mad.
Y'all, I'm gonna throw up. It does not change.
I watched it change in front of me, and it's
We're going to do a one proportion z-test, so you should write this down. Okay? I'm sorry, two proportion z-test. Okay? But we're going to have to introduce, as Hunter suggested, the idea of men versus women. So let's create we could do age. We could think that only only old people see gold and white. We could figure out some factor to look at the difference between.
some old people see brown and green. Mr. Hyde thinks it's green and brown.
It is gold and white, and y'all just need to get over yourselves. Okay.
So many colors now.
All right, so let's come up with the hypotheses, Sammy.
Hello.
Hypotheses. Ho-ha. Let's think of our song. Okay? When we talk about hypotheses for two proportions, you're going to label them always in terms of P1, P2, or we could say P male versus female. But remember, we're not using our hat in our hypotheses. It's always the population proportion. The null hypothesis often can be written this way. And since we decided as a class to do male versus females, we'll go ahead and make it male versus female context, if that's okay. There are equally number of males and females that see both white and gold versus blue and black. Now, I find it interesting because in my family, we have 2 girls and 3 boys. And my 3 boys all saw it blue and black, and my 2 girls saw it white and gold. So I thought, actually, that's the whole reason I came up with this idea to do this problem, is because I really thought there was that gender had an influence. But I see so many girls over here, so I don't know if I believe that. But can you think of it? So remember, we always write the equation, right? What would the context part of the hypothesis written here? The proportion of males that see blue and black is the same as the proportion of females that see blue and black. Would you agree with that? Okay? And we'll stick with blue and black because there's more of you. Us white and gold people, we're just out. Whatever. Are you now a blue and black person, though?
I don't know what I'm looking at. I see, like, I was trying, like,
I feel like we're all, like, in some kind of trip or something. We're like, oh, sometimes blue and black. It is only white and gold.
I see the blue, and I think that's black. I can see the black, but then again, the gold is just right there, too, and it makes it black.
I don't even know what you're saying. That's weird. Okay.
Like, bottom or black, but I can see the gold a little bit.
I don't see any gold. I see all gold. All right. Anyway. Shh. Okay. So again, you would write it out here. Sometimes, and I'm going to write this and erase it, but sometimes you can see it written this way. Is that okay? It's the same thing. Would you agree? So I tend to usually just write them equal to each other, but you will see them in the book as a difference is 0. The difference between the two is 0. Okay? Okay. So that's a question we want to ask ourselves. Without looking at who's where and whatever, what alternative hypothesis do we want to say? Well, in my house, it appeared as though men saw it definitely more than females, right? Because it was all males versus females in my house. But it just depends on whatever we want to say. We could do a two-tailed test, but I think I'm going to go ahead and just say males is greater than females. Is that okay? All right, so the proportion of males is greater than the proportion of females that see blue and black. Are we good? All right. Are we clear with why this is now a 2-proportion z-test as opposed to a 1-proportion z-test? Okay, that's important. When you did your reading of chapter 22, were there any changes to the conditions? Don't everybody yell at once. Yeah, you know, don't hold back. So we're going to have to go through them again, okay? So let's do the conditions. We've named our test, by the way. So the conditions, well, let's just go. So the one is going to be what? Now we have to be very careful. How many samples do I have? 2. So I need to be clear about both samples. Both samples have to go through the tests. So what am I going to say here? Both samples were collected. Well, were they? Well, what can we assume otherwise? That our sample is representative, maybe, of what everybody thinks? So we'll assume both our females and males are representative of our population. We're going to assume that, okay? I'm not even there yet. Okay. The representative part takes care of the randomness, okay? Because we're definitely not a random sample. It's our class. So another way, because we wouldn't make that, that's not going to meet that condition. We can't assume it was a random sample because we know it wasn't. We were just sitting in here. But we're just going to assume that our class is representative. Okay? Okay? The 10% condition. You have to apply it for both males and females, for both populations. So we're going to have to come up with how many males were in our sample and how many females were in our sample. Am I going to be concerned with us, Tanner and Kyle and Erica and us over here, who see it as a blue and black dress? I'm sorry, who see it as white and gold dress? Nope, don't care about us. I'm sad for us. Do we have to include them in the sample size? No, because we're trying to figure out from our sample of people who see it blue and black, are there more, well, no, hang on. You're right. In our, were there more, yes, our sample size, we're all in the sample size, right? But percentage of people who see it blue and black out of the total. Yes, I'm sorry, you're correct. So let's write that down. So P hat for females and P hat for males. So how many total males did we have? Let's count you. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So out of, let me write in a different color that's going to show up. So 8 males and 7 of you thought it was blue and black, right? Okay. How many females are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay. So we had 12 females and 1, 2, 3, 4, 5, 6 of you. So half of us think one way. Did I count that right? No. 1, 2, 3, 4, 5, 6, 7. 7 of you. 7 of you. Okay. Now, what do we use that information to say here? That both 12 and 8 are less than 10% of the population of males and females, right? So we'll have to be specific. So 12 is less than 10% of females. And we also need to say that 8 is less than 10% of all males. Okay. What's the third condition? Say again? Right, greater than 10. So we're going to have to do it for both NP and Q for males and NP and Q for females. Okay? Got to do it. In other words, you're going to do 4 inequalities here. Got to do it for both. Why is it doing that? And our sample size is not going to be big enough here because I don't think we're going to meet this condition because we're a small class, right? I'm almost positive we will not, but that's okay. We're just going to proceed with caution and do it anyway. All right, so we would check N female Q, NP, right? Greater than 10, and then N male, P male greater than 10. We'll also do it for Q. What did I do wrong? Oh, that should be males. All right, so what was our sample size of females? Was 12, right? So we have 12 times something. Is that greater than 10? And then the males, we had 8 of us. All right, so we have to use P hat and Q hat because we don't have the actual population parameter here. So we're going to, I don't know why. It's really making me sad. 7 out of 12 and 7 out of 8, right? All right, so females was, 7 out of 12, and that would give you 5 out of 12 here. And then it was 7 out of 8 and 1 out of 8. So way didn't meet the conditions. Would you agree with that? Okay, so I get it. Matter of fact, none of them met the conditions. So that's because our sample size was too small, but we're going to move on. Are we okay with that? Sean, did I make a mistake? I didn't? Okay, well, can we just move on, though? Because I can't count. I'm sorry. But thank you for double checking me. I appreciate it. Where were you 5 minutes ago? You're good. I appreciate it, Sean. Thanks. So we've checked our conditions, we've named our test, we've set our hypothesis. Granted, our sample size is really small, but I still wanted to do it. We okay? All right. What's the next step? Finding the new standard deviation, or standard error in this case if we don't have a P. We're going to use our claim though, right? Ooh, what do we do here? Okay, so let's look. So I'm going to use a new page. Okay, so we need to find our new. Do you agree with this? And what was our sample sizes? Oh, I said they were 12 and 8. Oh, no, that's wrong. Sorry. Okay, so we're going to write those underneath there. Okay, what goes on the top here and here? Sorry, Tim Settle. Whatever. You always have to make me laugh every day. What goes there? So we're really using p hat here because we don't have a claim. Would you agree? Okay. Well, maybe. Do we have like a difference? There is no difference? I mean, what could we say 0.5, 0.5 here? Did y'all read about it last night? Okay. I don't think you read it because this was a big deal towards the end of the chapter. For example, look at page 502, where it says the 2 proportion Z test. And there's a word there. And what does that word there, what is the strange word that you see? Pooled. Do you see the word pooled? Okay. So I want you to read over that again, starting on page 501, where it says everyone into the pool, and decide what they mean by the word pool. What does pooling do? And what do they mean by pooling? What numbers go in that formula? Because that's what's going to make the difference. Okay? So I'm going to pause the recording for a minute, and then we'll move on. Find it. So when you're reading pages 501 and 502, there is one sentence somewhere that tells us why we have to do something called pooling. Okay, so I'm going to erase this, and I'm going to write pool with a question mark. And there is a sentence somewhere in there that tells us about that. Okay, so let everybody have a chance to find it, and then both you and Devin found it, I think. Look on page 502 in the box that says 2 proportion Z test. Do you see the second sentence underneath the null hypothesis? Where it says, because we hypothesize that the proportions are equal, right? The males and females are the same. We're going to pull the groups to find our pooled p hat. So that's what we need to do. So what would our pooled p hat be in our case? Well, it's 8 plus 12 down here because we had 12 females and 8 males. Sorry, Sean. Okay. And then what went in the numerator? Uh-huh. The number of successes, right? So it's just there were 7 males and 7 females, okay? That saw the blue and the black, right? Okay. So our pooled Q hat, our P hat, is 14 over 20. And we can reduce that if we need to. What would that be? 7/10.7, whatever. Okay. All right. Okay. We can also find our standard error. Would you agree? We have that formula on page 502. So let's do that. Okay. Now what? Let's plug in our information. So 0.7 times 0.3 over 8 plus 0.7 times 0.3 over 12. So that's where I was coming from. What numbers go in the top of our standard error formula, okay? So that was my initial question 5 minutes ago, is what numbers went up here? Well, you had to pool to be able to get those numbers, okay? Yes? Okay, that was the key. All right, so let's go ahead and continue our hypothesis test. Can you just, let's find a number to figure out what this is real quick. Sorry, Charlie, you can just go ahead and fast forward. All right, I got it to be 0.209. Sound about right? All right, so that's our standard deviation of the difference. Okay, is 0.209. Now what? Think about hypothesis test steps. Huh? Test statistic, or we can just jump to the p-value. Are we okay with the p-value? And how do I find the p-value? Normal CDF? Yes, Devin. Go ahead. Huh? Okay, on the calculator, it'd be a 2 proportion z-test, yes. Okay, I agree. But how would we find the p-value? What do we want the mean to be? 0. The difference is 0. Would you agree? Okay. What was the pooled difference? Or the pooled p-hat? 0.7. We're trying to figure out males are greater. I think that was our null hypothesis, wasn't it? So we're looking for that. You okay so far? Okay. So we're going to say normal CDF. 0.7 E99, mean, standard deviation. P-value is very small. What does that mean? I'm going to reject the null, right? I want to reject the null. So let's go back to our context. I'm rejecting that. I have evidence to suggest that. Thank you. That's exactly right. We have evidence to suggest that that there's a higher proportion of males that see the dress as blue and black than women. Okay? And that's what we would say is our conclusion. If I can ever get this to slide down, it'd be nice. Well, me and the smartboard are going to have words. So this evidence that I collected, albeit from a small sample, okay? All right, so we have evidence to suggest that the proportion of males that see the dress as blue and black is higher than that of females. Okay. How do we feel about a 2 proportion z-test? I know. One example is probably not going to cut it for you, but that's honestly all the material. There's nothing else to add to it. The new information that you have to take from it is you have new formulas for a confidence interval. That's really all you have to worry about for a confidence interval, really. But for a hypothesis test, to find your standard error, we're going to be pooling. Standard deviation, we're going to be pooling, right? Well, and that's going to be our null hypothesis almost always. Okay? So that's a really good question. You pool if our null hypothesis is that they're the same. Okay? Yes.
Should law on where it's supposed to be black and safety two? Do you see two distinct different colors?
No.
I do.
Because this is the last information with proportions, and afterwards we're going to move on to it's really a totally different distribution. It's called a T distribution. I think you are better off going over the homework and then taking the quiz on Thursday, as opposed to going over the homework, starting a whole different distribution, completely different than this, and then coming back and taking the quiz after a long week, after the weekend on Monday. So that's just my opinion. So I really think you are better off taking the quiz on Thursday when it's still fresh in your head. Okay? So you have two confidence interval problems and two hypothesis test problems. On your quiz, you'll be asked to do one of each. Okay? So it's really just kind of, you have to do these you have an even and an odd of each, so it should help you be able to do both. Okay? And then we'll move on, if we have time after the quiz, to our totally different distribution called a T distribution. Okay? So you have a quiz too. See you guys then.